Let us now spend a little time discussing units. In the physical sciences, especially in the peer-reviewed scientific literature, you will notice that the SI units are used. The acronym SI stands for Système International in French, or International System in English. On this slide, I have listed the 7 primary or base SI units, from which all other units, that is, all secondary units, are derived. You will need to learn what is contained in the following table. The 7 SI units are the meter with symbol M for length, the kilogram with symbol kg for mass, the second with symbol S for time, the Kelvin with symbol uppercase K for temperature, the mole with symbol MOL for amount of substance, and also the ampere with symbol uppercase A for electrical current, and the candela with symbol CD for luminous intensity. From the 7 primary units, all other units can be derived for all other physical properties. Let us examine a few examples of secondary SI units, starting with the unit for volume. A common mistake is to assume that the SI unit for volume is the liter. This is not so. To find any secondary unit, we always start by writing the property of interest in terms of properties associated with primary units. So for the volume of an object, we will remember that regardless of the shape of the object, the volume is always proportional to the product of the 3 dimensions. For example, the volume of a cube of side A is a to the power 3, or a cube. The volume of a sphere of radius r is 4/3 of pi r cube. So the SI unit of volume is obtained by cubing the unit of length, from which we conclude that the SI unit of volume is the cubic meter. As a next example, let us determine the SI unit of density. Density is expressed as the ratio of mass over volume. So the SI unit for density is the ratio of the SI unit for mass to the SI unit for volume, which is kilogram per cubic meter. As a third example, let us derive the SI unit for molar volume for a pure substance. The molar volume, denoted by V sub m, is expressed as V, the volume of that substance, divided by N, the number of moles of that substance present in the volume V. So the unit for molar volume is cubic meter per mole. This table, I have listed the secondary units for area, velocity or speed, acceleration, force, work, heat, energy, pressure, and power, quantities that we will use in this course. Please review for each property the equation used to derive the unit for that property. Note that when the units become a little too cumbersome, new names are used. For example, the secondary units for force is kilogram times meter per square second. Instead of using this long unit, we will use its equivalent, the Newton, with symbol N. Similarly, we will use Pascal for the SI unit of pressure, and Joule for the SI unit for work, heat, and energy. You will need to memorize each of the units discussed in this table.